Good morning. I hope you guys are having a great Tuesday. Today is February 4th, 2025, and today we're going to be talking about how you can determine the solution of problems involving areas of a triangle. So, if you notice in the success criteria, we have four success criteria that are the same as the success criteria from yesterday when we were talking about area of rectangles and parallelograms. So the first thing for our success criteria is we want to identify the shape and its dimensions. Now, in the case of a triangle, the dimensions are going to be base and height. Once you have those dimensions, then we're going to go ahead and write the correct formula for the area of a triangle. Then we'll be substituting those dimensions in to our formula, and then we'll solve the equation for any missing values we might have. So let's go ahead and jump right into the first example. Here we have a triangle with given dimensions, and we're going to use those dimensions to determine the area of that triangle. So I'm going to go ahead and start by underlining keywords or circling keywords. So going back to the first success criteria, where we have to identify the shape and its dimensions, you'll notice that in every problem, the shape is given. In this case, a triangle. Also, notice here we are being asked to find the area of the triangle in square centimeters. So we want to determine what our dimensions are. If you remember from yesterday in a parallelogram's base was what the parallelogram set on. So it's usually the bottom line. And in the case of a triangle, that is no different. So our base is going to be 3.5 centimeters. Now, a little bit different, but not much different from the height of a parallelogram to the height of a triangle. The height of a triangle is actually going to be the perpendicular distance here from the opposite vertice to the base. So notice here I have that line going from this vertice to the base, and it is perpendicular to the base. So our height then is 1.5 centimeters. Here we have our formula for area of a triangle. Notice it's a little bit different than the area of a parallelogram or a rectangle. It is actually 1/2 times base times height. We have our base, which is 3.5 centimeters, our height, which is 1.5 centimeters, and we're looking for the area. So if I set everything up and I substitute in my dimensions, I should get 1/2 times 3.5 times 1.5. I'm going to go ahead and convert those mixed numbers into improper fractions, which will give me 1/2 times 7/2 times 3/2. And working from left to right, since it's all multiplication, I'm going to start by multiplying 1/2 times 7/2, which will give me 7/4. And then I'm going to multiply 7/4 times 3/2, which gives me 21/8. I'm then going to simplify 21/8 back into a mixed number, which is 2 5/8. So the area of our triangle in square centimeters is 2 5/8 centimeters squared. Okay, now let's go ahead and look at that second example. We have a carpenter who uses a rafter square that is in the shape of a triangle. The dimensions of a rafter square are shown in the diagram. So I want you to pause this video for just a minute and go ahead and draw that diagram onto your paper, because you'll notice you don't have it. We're going to go ahead and label the sides of our triangle. All right, now that you're back, let's go ahead and find our dimensions. So we know we're dealing with a triangle, and our dimensions here are going to be, well, of course, we have the formula. And then we have our base. Again, that's the side that the triangle sits on, which is 9.5 inches. We have our height, which is 9 inches. And we're going to be looking for that area. So using that area formula, A equals 1/2 base times height, I'm going to go ahead and substitute in my base and my height. And I get 1/2 times 9.5 times 9. I'm going to go ahead and multiply 1/2 times 9.5, which will give me 4.75. And then again, I have to multiply by 9, which will end me with 42.75 square inches. So the area of the rafter square in square inches is 42.75 square inches. So if you guys have any questions about any of these examples that we do, feel free to come ask me today after school, as I will be back around lunchtime today. All right, last example, we have a decorative mural on a bridge in the shape of a scalene triangle. The area of the triangle is 168 square meters. The other dimensions are shown in the diagram. I want to know, what is the height of the triangle in meters? So let's first talk about a scalene triangle. A scalene triangle is a triangle that has 3 sides that are all different lengths, as well as 3 angles that are all different measure. Okay, so important things that we are given in this problem, we are given area of the triangle is 168 meters. And we are looking for the height of the triangle. Okay, so if you notice, our base, the side that it's sitting on, is 24 meters. And we're going to be looking for that perpendicular distance that is opposite of the base. So we've got our formula for area of a triangle, 1/2 base times height. Our base is 24 meters. We're looking for our height. And our area is 168 square meters. So I'm going to go ahead and start substituting into my formula for area of a triangle. And I'm going to go ahead and substitute in for A, which is 168. And I'm going to substitute in for B on the other side of the equal sign, which is 24. So my current equation is 168 equals 1/2 times 24 times H. I'm going to go ahead now and start solving for H. So the first thing I need to do is I need to get rid of that 1/2. And in order to do that, I'm actually going to multiply both sides by 2. When I multiply both sides by 2, I end up with 336 equals 24H. So now this is an equation that I'm used to solving. I can go ahead now and eliminate that 24 by dividing both sides by 24 to get H on one side by itself. When I do the division, I should get 14 equals H. Therefore, the height of the triangle in meters is 14 meters. Okay. Again, if you guys have any questions, please feel free to come by after school. I will be around this afternoon. Now I want you all to do your check for understanding. What is the area of the obtuse triangle? We have our base, our height, and you will also notice that we have a slant height given. Once you finish your check for understanding, I want you to go ahead and put your answer into Google Classroom for this assignment and submit that to me. Then you'll be doing your independent practice, which is on the next page of the packet. It is front and back, I believe there are 8 questions, and whatever you don't finish in class today will be homework. All right, I'll see you guys later. Have a great day.